Hi, this is Mr. Manley. In this video, I'm going to look at finding a difference quotient. And this is a problem that students have some difficulty with. I'm going to show you how to do it, and then I'm going to show you an error that students make. And some students will still make that error, but hopefully we'll catch a few and prevent them from making it. It's really just about notation. This notation here, this is, I've got a notation for a function, and then I am evaluating this expression, which is called the difference quotient, based upon this function. And this function can change. Again, I mean, we have this function, f of x is 3x squared minus x plus 5. I could have another function like f of x is 2x plus 3, and any number of other functions that I'm going to evaluate the difference quotient based upon the function that I'm given, all of the infinite possibilities that there are for functions. So the difference quotient here begins with f of x plus h. So what does that mean? That means that I put an x plus h in for x in the function f. And I have two x's there. So I'm just going to do that substitution. So this will be 3, and then I put an x plus h in for x, minus I put an x plus h in for x, and then plus 5. So that piece there, that part there, that's f of x plus h. And then where am I at? So I've done this. Now I go minus. And then it says f of x. Well, I know what f of x is. It's just given right there. And I'm just going to subtract that. Let's put parentheses and make sure we subtract the whole thing. And then finally over h. And of course, the challenging piece of this, another challenging piece of this, is simplify your answer as much as possible. And in simplifying an answer, there are some pitfalls for students. This first part here is 3, and I'm going to go x squared plus 2hx plus h squared. So there are some students who will just want to do x squared plus h squared. But remember, there's a FOIL here, and there's this middle term, 2hx. And then I've got minus, all right, this is getting a little cramped here, so let's give ourselves a little bit more space. So 3x squared plus 2hx plus h squared. And then I've got minus x minus h. We're getting that here, minus x minus h, plus 5. And then I'm going to make sure that I subtract by distributing the negative to every term in that expression. So that's minus, and then so I have the plus 5, and then minus 3x squared plus x minus h. So see, I distributed minus this, minus a negative is plus, and minus 5. Okay, so that's our numerator divided by h. And now let's just go ahead and combine our like terms. So I've got 3x squared. I don't think I have any other x squareds, do I? Oh, I do. I missed this squared here. So if we look here at this, that squared, I didn't bring that down. So it's 3x squared there. So that's a square. So that's 3x squared minus 3x squared, so that zeroes out. And then I've got 6xhx. So do I have any other hx's? No, it doesn't look like it. So I've got 6hx, and then 3h squared, and no other h squareds, so that would be plus 3h squared. And I've got minus h, and minus x, and then there's a plus x, they zero out. Minus h, bring that down. Plus 5, minus 5, so those zero out. And then over h. but it says simplify, so we have to keep going. I'm going to go equals, and I see a common h here. So if I factor out the h, I'm left with this expression. Like so. So we can check that. So I have 6xh, 6xh or 6hx, and then I've got 3h squared with that. So there's 3h squared, and I've got minus h. So that all checks out. H's cancel. We see that. H cancels here, and that's my answer, 6x plus 3h minus 1. And there's a lot of interesting depth to this and what this means and why it is significant, which I'm not going to go into here. What I just want to do here is go ahead and look at the big pitfall error that students will make. This is an error that even students who do typically pretty well at math will make this error. And what is going to happen is that a student will want to do f of x plus h, and they will do it like this. They will do f of x, there's f of x, and then they will go plus h. And the thing is, so what this is, this here, this is f of x plus h. But notice, that's different. This and this are not the same thing. But still, that's what a lot of students will want to do. Maybe they're just misreading it, or it just seems simpler and they want to do it that way. But this is a big error. Now, I have a fail-safe or a backup plan for you to tell if you've made that error. And students will still make it, even though I show you this backup plan. So the backup plan here, let's finish as if we've done the first part correct. And then I go minus 3x squared minus x plus 5 over h. And then I'm going to simplify. So watch this. 3x squared, and then here I've got a minus 3x squared. So that zeroes out. Minus x, and then here I've got negative x. That's plus x. So minus x plus x, that zeroes out. Plus 5, and then here I've got minus 5. That zeroes out. And what does that leave us? That leaves us with h over h, which is equal to 1. And what I am telling you now is that if you ever have this difference quotient problem and your answer comes out to 1, you did it. You made the error. You made the common error. And this common error that I'm describing, if you execute it like this, it will always come out to 1. So if you ever are doing a difference quotient problem and you come out with an answer of 1, you're wrong. You made an error. And what's more, you made the most common error that students make on this. So hopefully, if you see that you made that error, you can go back and fix it. But if you can't go back and fix it, at least you can acknowledge it and know that that's the error that you made.